Okay, so we're talking about somebody asked a question. Alex asked a question. Would you say Mongo is better than SQL, or is it just more compatible with MERN in general? So there's sort of two schools of thought. There's two real types, bigger types. Now there's tons of different little types. If you go into like a SQL and a NoSQL, there are more in there. There's like key value that you can pull in. There's called graphs. So there's GraphQL. There's sort of different variations of each, but then in all reality, sort of the big two ones we're going to have are SQL, SQL, and NoSQL, SQL. Okay. So some of the, there's some pretty big difference. SQL is also known as tabular. Tabular. Sorry, I can't really write. I'm not at my normal desk. So it's tabular. What that means is, and this is a power, but then also a hindrance and why it's a little bit more difficult. Anytime you've got a SQL database, it's going to consist of rows and columns. And I know I did that backwards, sorry. Columns and rows, right? Where you're going to have some different values here. Usually you're going to have something called a primary key, which is a PK. Now, both of them have primary keys. It's a unique identifier. So both databases are going to have that. But then you might have like a first name. So I'm going to put FN. Maybe I'm going to put middle name, MN, and then maybe a last name, right? Just for this sake. Okay. So some of the power and why MySQL was created is you make sure that if something is in your database, it has the correct information. Everything is uniform, meaning that let's say we just have users. Every user is going to have a primary key. That's great. And then we can also require that our users have a first name, a middle name, and a last name. Now, here's where one of the limitations. Yes, thank you, Jordan. A created at and an updated at are awesome. Definitely add those. If you've never done that, you also, like if you didn't take Python, there's also a created at, which is a timestamp, and then an updated at, which gives us an idea of sort of when was the last time I was updated. What you can think of is like a password. You can kind of have a timer for there. If you've ever seen like, okay, there's password has to be, longer than 90 days, there's an issue there. Or when was this last updated? If we wanted to have that information, if you wanted to see a created at would be a great timestamp for like, hey, how long have you been with Facebook? Cool. You're celebrating 1 year with Facebook. They're going to use that timestamp to identify, okay, what is today's date? What is their created at date? Is this the same? Nope. Okay, then it's not their anniversary or whatever. So these tabular databases are great because they have some information and it's what you're going to get. You know that you're going to get some of this information, or that each row has to have every piece of information. So that's a benefit, but it's also a hindrance. Let's say, for example, that you are dealing with somebody like Adele, right? Or Oprah. Well, I guess Oprah Winfrey, but somebody who just has one seal is a great example. They just have one name, right? Well, kind of part of the issue is that if they just have a first name, they're not allowed to not have a middle name and a last name. So this could be none or null, right? It can be any of those, but it has to be something. There has to be a value with each of these. And so what part of the hindrance is then now everything has to, like if you've got a ton of different attributes, maybe it doesn't apply to somebody if there's a prefix like a doctor or a suffix for like, Esquire or attorney or whatever the other thing for attorneys are, or PhD or whatever. If somebody doesn't have that, there still is taking up space in data because you're still holding a value for that person, even though it's just null or none, right? So that's like a positive and a negative. It is easy to query, easier. It's SQL language, right? So it's easy to query, but again, you are holding all this information, even if somebody has one name, like seal, you still are holding all these values. So your data can grow a little bit. Now, NoSQL stands for not only SQL. So it's not like not SQL, because you can, in some of them, you can still do SQL queries on your data. And there's different tools and stuff to use that. But this is called, and so it's tabular or structured is another word you'd call it. Structured. TURED, sorry. And then this one is semi-structured. Semi-structured. This is just for Mongo, DB specifically. And a lot of semi-structured is going to be kind of your more popular. Now, where these use tables, NoSQL uses something called documents. MENTS. Sorry, I'm terrible at writing with this. These are documents. What's nice about it is you can have and set up a structure. So you can say, hey, there's going to be, and these are all in JSON, which is, you can just think of those as JavaScript objects, which is JavaScript object notation, right? And then you can say that there's a key of first name, there's a key of middle name, right? You can say that there are some of these things that we can expect, and we will do this later in the class. But what's nice is, let's say they don't have a middle name and a last name, then when they are created, their document just doesn't have that, right? You're able to have things that aren't necessarily matching. You could have a document, you could have documents of users. They would still have their primary key. They'd still have their unique identifier, but they don't have to have this middle name and last name, which is nice because they can add in something like doctor. You could have Mr. or Mrs. if they choose, some of these things that are optional. It can grow or shrink depending on what sort of data you have, which is really powerful from a data collecting side, right? So you're no longer trying to say, okay, if this is not, if there's no validations or they choose to not put a middle name, then we're going to make it null. Like, you don't have to deal with that because the document can expand or it can shrink depending on whatever you want to do. So that's part of it. Again, it can also grow. It's semi-structured. You can lay out some of that. Are there any questions so far of this before I get into one of the big topics of why NoSQL databases are growing sort of at a rapid pace? Any questions on this? Oscar, I'll get to your question in a second. Okay. So the second thing is that SQL was really nice because what it allowed was not only, so it was, again, a hindrance and a benefit. And because it was so structured, you can make sure that your data is clean. So there's this idea in data management called ETL or ELT. Don't know why I did my E's differently. I'm sorry. ETL stands for extract. Actually, you know what? I'm just gonna do this. This is probably way easier for everybody. I don't know why I didn't think about this. Cool. So ETL stands for extract, transform, load. Now, what extract, transform, load means is when you're collecting data, because data used to be very, very, very expensive, right? Back in the day when you had your own servers and you had to manage your data size, what you would want to do is you would extract data. You get data from your user. You would transform your data, basically say, what can I use? What is good data? What is bad data? What do I not need? And I only want to keep the essentials. I only want to keep what I'm going to need for this, said project or whatever that we're working on, said feature. And then once it's all transformed, part of the data cleaning, that's a huge part of data science, is you're cleaning data. I know Justine is currently walking through the data science stuff. That's like 85% of the job is cleaning your data. Not really doing like AI stuff. you're transforming / cleaning your data, and then you load it onto your database, load it onto some sort of SQL server or some sort of cloud or on-premise, meaning that you own your own server, right? And the point of that is we will only want to keep what's essential. We don't want to pay for extra space. That's how it used to be. Old method. Now with ELT, what has actually happened is data has gotten very cheap. Once cloud computing and AWS and Azure came into play and GCP, actually data has gotten really, really, really cheap to store. There's things like S3 buckets, there's MongoDB, there's, XYZ, to where now people are following something like this: extract, load, transform. So this is the new model, ELT, extract, load, and transform. What this does is it allows us to extract as much data as we can. And then because it's so cheap, we can actually just keep our data. We can keep all the data, because part of the issue was whenever we would do ETL is sometimes we would transform and clean our data, get rid of things we didn't need because we're working on said project or whatever, projects in scope. But then 6 months down the road, we wanted to do something different, but we already got rid of the data that would have been helpful for our new tool, right? And that was just part of the process. It's like, oh man, now we're going to need to get more data, et cetera, et cetera. What this allows is we can extract this data and load it into a data lake or load it into something like a big S3 bucket. And then as we are needing different features, as we're needing to do different studies, if we're wanting to see injury rates of X, Y, or Z or whatever, we can then transform our data to fit, and we're not getting rid of any data because now data is cheap, right? So this is when cheap data, and this is expensive. So because of that, this is where, and I know this is a long way to say, this is where the non-relational, the NoSQL, so also non-relational, I'll go over that in a second. That's where that's really coming into play right now, because now we can just keep data and it can be semi-structured. And so if we're collecting as much as we want, data is becoming king, right? That's why Microsoft is so popular or rich. That's why Google and Facebook, because they have so much data and they're able to store it that way. So that is sort of this idea behind ETL and ELT, because because data is cheap to have now and to store, we can actually just collect as much as we want. And what NoSQL databases allow us to do is extract as much data as we want, load it into a data lake, or keep it in some S3 bucket or some other cheap way to do it, Glacier S3 bucket, and then we can transform it as needed. The other drawback is in a MySQL database, you have these things called tables, right? Everything's tabular. So there are these tables. So let's say we have user and I don't know, post, right? We're on Facebook. And so we have like a user table, and it's going to have their primary key. Oops. So we have like user, and then we'd have like a comment. Let's say we had a different table for comment. Well, then we'd have to create these relationships, right? And say, okay, this user can be associated with comment, or comment can be associated with user, blah, blah, blah. We had to create these relationships. A big benefit with MySQL or NoSQL is that you don't have to, it's called non-relational. We can do different things to associate the two, but they don't have to be set up in this specific way. That was kind of a challenge, is if you have your database set up in a specific way, if you wanted to alter it, that became more of a difficult thing. So at the current moment, NoSQL databases often allow us to have a little bit more flexibility in what we're trying to associate with our data. Like we might have to do the association on our end, but now we don't have to go in and change the ERD or the entire diagram of how our database operates and the relationships associated with that, which can be a hindrance. Now, I would say there's a lot of legacy companies that are still using this. And especially the government is still using like an ETL, because anything in the government's like 10 years behind. So that's still popular. It's still a good thing to know. And a lot of people will use it, especially for like Java. Java's an older language, right? It's still kind of considered like considered a legacy language, but that doesn't mean you don't want to learn it, because a lot of companies are still using it, if that makes sense. Okay. That was like a breakdown of NoSQL versus SQL. Any questions on that? Alex asked, NoSQL can essentially save you a lot of space. It can, but it also can allow you to save more data. So it's just dependent on how you use it. There's a few things you can do. You can actually save more data. So sometimes you might find yourself, if you're just saving, you might actually have trash, like more trash data. That's where some of the benefit of a SQL database comes in, is because you are sure that your data is good, right? Because you've had to sort of, you can do like extract, load, transform. You just might have to have more tasks, and it might have to be more granular, right? With a SQL database. But you are assuring that things are going to work, right? It has to be in a certain way, versus if you're doing like a NoSQL just document, maybe they just give you their first name. Unless you have proper validations, or you're storing just sort of this junk data, you're just getting this partial data, it can actually lead to having bloat. And then there's also other ones like graphs within NoSQL that actually can, like there's one called CouchDB that's based off of nodes. This is probably way too in the weeds, but basically you create a user and they're like a node, and then you can connect them with other nodes. And that's just sort of from a high level, that's how it's working. And then these nodes have more nodes. These are all data points. The issue with that, this is like CouchDB and AWS. The issue with that is, let's say that your user wants to be deleted. Well, you can delete this information. This node's holding their information. You can delete their information, but an issue would be is you can't delete this node because it's connected to all of these guys. It's connected to this guy and this guy and this guy. So a big issue with CouchDB is that though you're deleting data, your CouchDB is growing because you can't delete this node in a sense. And so then you find yourself saying, oh no, I have this ever growing, database that'll never reduce and shrink, versus if you had something like with a SQL database, if you would have gone that route, or even just another one, then as you delete data, the amount of data you have shrinks, therefore you're paying less. So it can be hit or miss. It is a use case thing, depends on what you're trying to do, what your company's trying to do, and really how it's working. And sometimes you look and you're like, okay, CouchDB is not working. How do we migrate databases to another tool? And that's like a data migration. And that's where data scientists will come in and handle that. You guys hopefully won't have to worry about any of that. So. Somebody said a little confusing on how you organize it though. In my head, picturing it like a notebook full of all this info, then querying. Yeah. So it would just be like a document. And when we get to Mongo, because you guys haven't dealt with that, it's just a little bit more confusing, but yeah, you can think about it like a notebook, and each page is a document, and you can just go through and, one might have a first name, a last name, and a email. And the next one might have a first name, a middle name, a last name, and an email. The next one, right? And so you just kind of go between each page just like that. So that's a good analogy. Somebody said, so it really depends on what you need from your data, but neither is really better. Yeah. So I guess it would, yes, in a sense. And the nice thing is you can kind of attach both. So if you wanted to attach this entire project to a MySQL, you could do that. It is like if you wanted to do, I guess it'd still be MERN because it's MySQL versus Mongo. So you both start with an M, but if you wanted to use a tabular database, you totally can. You just have to set it up differently. And that's the same thing. Like React is great with a Node backend, but you should also have it with Python. You can have it with Java. Like there's still other tools. React is not just for MERN. Tons of things can be used for, like React can be on top of C#. It can be on top of Java, it can be on top of Python, it can be on top of maybe Rust, maybe not Rust and Go. I'm not quite sure. I've only done a little bit of Rust and Go. Somebody said shoving it in a bag for space versus a bunch of boxes for each. Yeah, that's it's kind of a great way to do it. Think about it. Yeah, like if you had a bunch of clothes, instead of just, I guess, Mongo or NoSQL, the idea behind ETL is that you would just put all your clothes in and then you can pick through them later versus, okay, your friend's giving you a bunch of clothes that they're going to go to Goodwill and they're going to go to Goodwill and like give all these clothes away. And they say, go ahead and pick through them first. ELT would be, I'm just going to take the entire thing. And then as I'm going, I can pick through and get what I want, but I'm going to keep, and I'm going to have access to every shirt and pair of pants. ETL would be, I'm actually going to go through every single one, decide what I want to keep, get rid of the rest, and then keep that. But then if you're like, man, I really wish I would have had that blue shirt, it's now at Goodwill and you can't have that anymore. So that's a good analogy. I'll probably use that much more. That's a great analogy, actually. Okay, I'm going to clear this. Somebody said, I feel like just login info could be on MySQL and all the other stuff on Mongo. Now you could, your setup would be pretty rough. But yeah, I think it's not a bad understanding to also have that you can have different databases for what you're trying to accomplish. So if you have like IoT data, which is Internet of Things, so anything that connects to the internet, if you have IoT data, that might be stored in like a Parquet file, which is just a type of file in the cloud, versus you might have a database that somebody logs into of users, and that might be stored in a relational database or of a document DB, which is a MongoDB cluster in AWS. Like you can, they don't have to, not all of your data has to be on the same database or the same tool. You can pick your tool. And that's really where the advantages of the cloud is you can have a database for users that you call upon whenever you want, users of, customers that you call upon, and you can keep those separate. They don't all have to be within one piece of, or one tool within the cloud. Cool. Okay, I'm gonna stop recording. I'm gonna answer a question.